Java, as a powerful and versatile programming language, offers a robust mechanism for organizing code into manageable units. This mechanism is known as packages. Packages act as containers, grouping related classes and interfaces, much like folders organize files on a computer. This organizational structure is crucial for managing large projects, promoting code reuse, and preventing naming conflicts. In essence, Java packages provide a form of namespaces, ensuring that classes with the same name can coexist harmoniously without ambiguity. Imagine a scenario where multiple developers are working on different parts of a large software project. Each developer might create classes with similar names, leading to confusion and potential errors. Packages resolve this issue by providing separate namespaces for each developer's work. This means that a class named FileHandler in one package is distinct from a class with the same name in another package. This separation ensures that each class can be uniquely identified and used without interference. Namespaces are a common concept in many programming languages. They provide a way to organize code into logical units and prevent naming collisions. Just as a library uses a cataloging system to organize books by subject, packages organize Java code into manageable categories. This organization makes it easier to locate and reuse specific code modules, streamlining the development process. By understanding the concept of namespaces and how they are implemented through packages, Java developers gain a powerful tool for managing complex projects and ensuring code clarity. Packages are fundamental to the Java language, and mastering their use is essential for any aspiring Java programmer. In Java, packages are not merely conceptual entities. They have a defined structure and purpose. A package is essentially a collection of related classes and interfaces grouped under a unique name. This name acts as the package's identifier, distinguishing it from other packages. The package name itself follows a hierarchical structure, using the dot as a separator. For example, the package name com.example.vehicles indicates a package named myapp within a package named example, which is itself within a package named com. This hierarchical naming convention not only provides a logical structure, but also helps prevent naming conflicts. By nesting packages within one another, Java ensures that even if two companies use the same package name at a lower level, their full package names will still be unique. This hierarchical structure also mirrors the organization of files in the file system, making it easy to map packages to physical directories. Every Java class belongs to a package. If a class does not explicitly declare a package using the package keyword, it is considered part of the unnamed package. However, using the unnamed package is discouraged for any serious Java development, as it undermines the benefits of package organization. Explicitly declaring a package for each class ensures that the code is structured and easily maintainable. The package declaration must be the first statement in a Java source file, preceding any import statements or class declarations. For example, the statement package com.example.myapp at the beginning of a source file indicates that the classes defined in that file belong to the com.example.myapp package. The use of packages in Java brings numerous benefits. One of the most significant advantages is modularity. By grouping related classes and interfaces into packages, Java promotes a modular design approach. This means that different parts of a software project can be developed and maintained independently, as long as the interfaces between packages are well defined. Modularity makes it easier to manage large projects, as changes in one package are less likely to affect other parts of the system. Another key benefit of packages is encapsulation. Encapsulation is a fundamental principle in object-oriented programming that involves hiding the internal workings of an object and exposing only a well-defined interface. Packages contribute to encapsulation by allowing developers to control the visibility of classes and interfaces. A class can be declared public, making it accessible to other packages, or it can have a more restricted access level, limiting its visibility to within the same package. Perhaps the most crucial advantage of packages is namespace separation. As mentioned earlier, packages prevent naming conflicts by providing separate namespaces for classes. This means that two classes with the same name can coexist without ambiguity, as long as they belong to different packages. This is particularly important in large projects where multiple developers might independently create classes with similar names. Namespace separation is not just about avoiding errors, it also contributes to code clarity and maintainability. By organizing classes into packages, Java makes it easier to understand the structure of a project and locate specific functionality. This organization simplifies code navigation and reduces the cognitive load on developers. Section 4. Java packages in the file system, a real-world perspective. The concept of packages in Java extends beyond the realm of code organization. It has a direct correspondence with the file system. Each package is mapped to a directory in the file system, creating a physical representation of the package structure. This mapping ensures that the organization of code in packages is reflected in the organization of files on disk. This consistency makes it easy to manage Java projects, as the structure of the code base is mirrored in the file system. The mapping between packages and directories is straightforward. For example, a package named com.example.myapp would correspond to a directory structure of com.example.myapp. Each component of the package name becomes a subdirectory within the preceding directory. This hierarchical structure ensures that the package structure is faithfully represented in the file system. Within each directory, the Java source files for the classes belonging to that package are stored. For instance, a class named FileHandler in the com.example.myapp package would be stored in a file named filehandler.java within the com.example.myapp directory. This direct correspondence between packages and directories simplifies project management, as developers can easily locate the source files for specific classes based on their package names. This file system mapping is not merely a matter of convenience, it plays a crucial role in how the Java compiler locates and compiles classes. When compiling a Java program, the compiler uses the package name to determine the location of the corresponding source file in the file system. This mechanism ensures that the compiler can correctly resolve dependencies between classes and compile the program into a functional executable. Section 5. Conclusion: the cornerstone of large-scale Java projects. In conclusion, packages are an indispensable part of the Java programming language. They provide a powerful mechanism for organizing code into manageable units, promoting modularity, encapsulation, and namespace separation. Packages are not merely abstract concepts, they have a direct correspondence with the file system, creating a physical representation of the code structure. The benefits of using packages are numerous. They facilitate code reuse, simplify project management, prevent naming conflicts, and enhance code readability and maintainability. Packages are essential for managing large-scale Java projects, enabling developers to work collaboratively and produce well-structured and robust software. Understanding the concept of packages and their role in Java development is crucial for any aspiring Java programmer. Mastering the use of packages equips developers with the tools to create well-organized, maintainable, and scalable Java applications. Packages are the cornerstone of large-scale Java development, providing the organizational foundation for building complex and sophisticated software systems.